Welcome. I am Francesco Chimienti from IRIA and Institut Polytechnique de Paris, and this video introduces you to an investigative journalism project we study concerning conflicts of interest. Our team developed a software system called ConnectionLens, tackling a recurrent issue in the field of data journalism, that is, connecting heterogeneous and independently produced data sources. To this purpose, the ConnectionLens system is able to ingest a set of data sources of different format, for example JSON files, HTML pages, or plain text files, and integrate them into a single graph. So I'm going to guide you through the different features and components of our system. Here you can see our graphical user interface that in the first place allows us to import a collection of data sources. We can drag and drop the sources here or explore the file system. In the following demo, we present a real-world use case as suggested by our partnership with Le Monde. So we focus on a specific scenario that is conflicts of interest in the biomedical domain. In fact, biomedical experts have a very central role in society since they usually end up advising governments and the public on health-related issues. However, to some extent, they are also involved into industry, sharing knowledge and work. Therefore, it is very important to guarantee that biomedical experts' advice is not influenced by some kind of interest. That might involve various organizations like corporations, industry associations, lobby or front groups. Anyway, the information needed to answer this matter is usually scattered across different data sources, thus preventing investigative journalism to find any kind of answer. So we have built a graph by loading 450,000 bibliographic notices in XML format by PubMed, corresponding to articles from 2019 and 2020, occupying around 900 megabytes on disk. Furthermore, we have ingested more than 42,000 PDF articles corresponding to such notices, and we found those on open access website. As a matter of fact, those PDF files have been converted into JSON files by the pipeline implemented in ConnectionLens itself, and only then actually ingested. So, these JSON files occupy about 340 megabytes on disk. Finally, we have crawled 781 HTML web pages from some website involving organizations that have been previously related to scientific expertise on sensitive topics, like for example the tobacco industry. So now that we have integrated our data sources into a single graph, we can query such a graph by keywords. In this example, we are querying two pharmaceutical organizations and a person that might be involved into conflict of interest. So we get different solutions that are ranked according to a given score. For each of them, you can also see their size, their score, and the number of data sources that are spanned. For example, let's focus on the first one. Our graphical user interface allows us to explore in detail each solution, highlighting different kind of entity nodes, for example, person nodes, organization nodes, and data nodes. We can explore each of the node in details. For example, let's focus on this data node. In this case, we are dealing with an XML node, as you can read on the right-hand side. At the left-hand side, we can see all the neighbors of such a node, and we can decide to expand them by type, all of them, or just select the one that we are interested into. In this case, let's look for all the data nodes neighbors. We can continue this way and explore the graph in an interactive way. Users can navigate starting from query results to see what other nodes are in their neighborhood, what other organizations, co-authors, etc. Eventually, we can save a given visualization and restore it for further and later usage. Once a visualization has been restored, we can easily continue to explore the graph. This concludes this demonstration. Thank you so much for your attention. You might find our project in our GitLab repository.